I guess we can start. We will have a very short presentation. My name is Bogdan Solga. I will present together with my dear friend Nicolas Boitout. We'll present scaling personalization using AI. It will be a presentation divided in two parts that we will decide together on the splitting, meaning a theoretical presentation which might be very short or a little bit longer depending on your level of knowledge, and the other one which will be a more practical, meaning a demo in which we will present the concepts and on which we will discuss way more details. The purpose will be for everyone to understand what we are doing, not to showcase some fancy words and everyone to leave afterwards just puzzled what the hell are they speaking about. So it's not the intent to show off some fancy words without you understanding them. So hopefully we've set the context entirely clear. I guess we are pretty much complete. If everyone will join, there's absolutely no problem. We still have a few introduction slides, so it will be just about very briefly about ourselves, short overview. I have been working as a trainer and consultant, especially in the Java ecosystem, more than 70 years of experience. So from development, tech leadership towards architecting and then training on the Java ecosystem. Currently working as an integration architect and AI enthusiast and proponent. Have been researching and have been working with AI since a few months ago and a big fan and proponent of. So very short overview. Nicolas, I will leave you.
Yes, 20 years in data science. I'm a bit close to the mic, I believe, no?
As you wish.
I'm currently the lead trainer of a business school that we started in Bucharest. Nothing related to tech, but I'm the lead trainer there. Yes, I'm actually teaching generative AI there. That's maybe the only connection. And I like to be this way, one foot in business, one foot in tech. So that's a good summary.
Together we have 3 feet in technical aspects and 1 foot in business domain. So a very nice balance. The intent of the presentation, so a user content personalization solution using some AI components and concepts, HuggingFace Hub and the goodies that it offers, vector databases, RAG ecosystem, retrieval augmented generation, and the LangChain framework to tie everything together. The very short question, which will come very soon, will be if you are familiar with these terms. If you are familiar with these terms, then my presentation will be, I don't know, gladly, hopefully, very short, because I will very soon allow Nicolas to take over the presentation of the actual demo, and on which we will discuss together and on which we will kindly invite everyone to ask questions. So. Short AI overview if needed, theoretical notions, and afterwards the demo. As I've said, the question will be entirely on this slide without any fancy fadings. Do you want me to present these overviews? Should I present them?
Yes.
Very briefly? Yes. So we have mostly yes. As I was envisioning, we had a discussion before the presentation, and I told Nicolas that my hope will be that everyone is familiar with these terms and that we will proceed directly to the demo. Because if they are already known, great, more time for showing demo stuff. Then I will proceed briefly with them. It won't be a long introduction. It will be a very short summary, but just so that we set the foundation detail, the foundation set of details that we'll use onwards. So. Artificial intelligence, overall a computer science field branch dedicated to creating systems that perform tasks which are usually requiring human intelligence. So learning, categorizing, decision making, anything. So using machine learning, as we'll further see, which is systems that are learning from a set of data in order to perform a series of tasks to improve our workflows. So that's the very short overview. So solutions that can understand human language, learn from experience, and which can also be improved in terms of experience and through human feedback called reinforcement feedback, so that they can perform better in their everyday work. You might have heard about LLMs, you might have heard about at least ChatGPT. There is of course, has been very popular since last year especially. Adapt and perform a series of tasks and operate autonomously. So that's a very brief overview of AI. We'll further see AI as a general domain, machine learning, which is a subset of artificial intelligence. I'll further present on the next slide what it is. So as the name states, specialized in learning from data. So learning, but machine learning, as we'll further see. Deep learning, a subset of, or a type of machine learning, again to be further seen. Natural language processing, the understanding of natural language, meaning what we are speaking, commonly speaking. And a subset, generative AI, which will be a part of what we will further explain and present, and which you might have worked with, you might have interacted, or you will further interact in the future, because it is that magical thingy that is generating either texts, very interesting texts, or images, or sounds, or movies, or whatever would be needed. So creating magic, in short. If at any point you may have any questions, considering that this is an overview, and I will be maybe a little bit on a fast-forward mode, but I will be on a fast-forward mode from a single reason, in order to proceed to the interesting part, the demo part. Okay, so if at any point there might be something. So as mentioned, creating systems that perform tasks usually requiring human intelligence, machine learning, learning from data, identifying patterns, and making decisions with minimal human intervention. Why? Because we want to automate systems to perform the magic and to perform the tasks for us. What are those tasks? I think the usual answer, or the most generally valid answer from our domain, it depends. So depending on what do we want to generate from, I don't know, a shopping list, or trip suggestions, to integrating a full software project. You might have heard or not about Devin, the first AI software engineer, not intending to scare anyone, but just explaining the direction towards generating things. So integrating a full software project through an AI solution. So making decisions with minimal human intervention. Deep learning, a subset of machine learning, so further specialization. NLP, understanding and interpreting human language, because we want to be able to speak with an AI solution, to ask it things and to ask a certain output, not to provide to perform that in a programmatic way. So again, the intention would be to naturally speak with it. And AI, generative AI systems which are generating data that resemble the training data. So all of these systems, the AI systems, or the LLMs, as you may have heard, large language models are AI models which have been built by processing huge amounts of data. So huge amounts of data, it always depends, but essentially they are trained. So they are trained from a huge set of data, and based on that data, they can generate new information. The essence, or the shortest summary that I can provide. Personalization, why do we want? So in the current era, information overload, we want to have a personalized experience. So whenever we are browsing, especially a shopping site, be that Amazon, be that eMag, whatever it would be, users will want a personalized experience. So nice to have. They will boost the user engagement, loyalty to that project, so providing a better user experience. So for that, the challenge would be to scale those experiences to meet the user needs efficiently. So we will see a technical solution in terms of the components, and we'll further get to that. So challenges, technical, geographical, because most of the time these are distributed. Cultural, because different people may have different cultural, or will have different cultural behaviors and habits, and an AI system would need to accommodate all of these in order to perform those user specific recommendations. So that would be the end goal. So greatly improved personalization through a series of concepts, context, and technologies. We'll further see a summary for those technologies, meaning HuggingFace, VectorDBs, RAG, so to understand what they are doing. Nuanced user understanding, dynamic data retrieval, and of course aggregation between the data from two sources, as we'll further see, and handling and integration for that data. So as we'll further see, one of the reasons, reasons and use cases for them for these components is to aggregate data from multiple systems for a better user experience. So technologies, as we further see. We'll start with the first one. A very nice name and a very nice, in my opinion, a very nice initiative, HuggingFace. HuggingFace is by far the leading platform for NLP and AI tools, meaning natural language processing and AI tools, meaning a platform pretty similar, or let's say resembling a little bit GitHub, but much more powerful, having also Git repositories in the background. Vast library of a lot of retrained models, meaning LLMs, for the AI development. So a very easy to use set of models, also including open source ones and community provided, and also ones that the others which are commercial. So a series of them. Transformers library, thousands of retrained models, so provided either by enterprise communities or companies or by community. The transformers in here, what we are referring in short, it might not be common for you. The T in GPT is exactly this transformers library, meaning an architectural pattern which is at the core of the generative AI, especially for the text generation, to summarize it in the shortest possible way. A lot of data sets, so in order to be used and usable for training and benchmarking. Community and collaboration, a very powerful community, so a huge component from the AI ecosystem. Researchers, developers, businesses, whoever wants to integrate some state-of-the-art AI components in their applications can definitely and easily benefit from HuggingFace. I may quickly open it so that maybe you will have a, HuggingFace. Sorry, that should have been HuggingFace. So, a huge community of both models and meaning LLMs, especially with a lot of specialties for them. Data sets, there is also a possibility to create spaces in which people can deploy their own solutions. So if you're ever interested to begin something, a project with AI, you can very easily use HuggingFace or a lot of other tools, but definitely a lot of components from HuggingFace will ease the integration a lot. So HuggingFace with the very nice smiling face, because it is a face that is hugging.
Can you execute the code on Collab?
Yep, sorry?
Can you come back?
Sure, absolutely.
Just give me 1 sec.
Sure, sorry.
You can go ahead. I just want to be sure that we are still connected. Yes, good. It's not fully deployed.
Yeah, we'll further explain the deployment aspect, meaning the deployment of our application when we'll get to the demo part. Given that we will run it in a Google Colab space, meaning a virtual environment that is offered by Google, and which has in the background some powerful hardware devices, including a GPU, they need to be deployed in time, and it takes some time, and we do not to take the time from the demo, so that's why we put it in the background. So that's the shortest overview that I could think of for the HuggingFace. So a very nice component from the AI ecosystem. And as I said, very cute as well, because it is a face that is hugging people. Vector databases. Another very powerful offering component from the AI ecosystem. Databases which are specialized to handle data, meaning indexing and retrieval of what it is named and referred to as vector embeddings. But those vector embeddings, as we will further see, in short, are the text representation, or actually, let's say, the numbers representations of whatever the user will want to process. That might be text, might be images, might be video, might be audio. So high-dimensional vectors, you might have heard the word tensor, that's what they are referring to, storing data in a machine-understandable format. So that's why we want to store the data in that, so machine-understandable representation in short. So high-dimensional indexing for them, so searching through through that data, so for any application that requires fast similarity search, meaning to search some similar terms and to have related terms, vector databases were conceived for that. There are several databases. We won't get into a lot of specifics, as we'll further see in our demo. We will use one of the I think it's open source database. It's called FICE, but as we will further explain, it's open source. Yeah. As we will further explain, we will want to everyone to understand the high-level concepts and to just know that any database specific or any specific component, it's something that can be further improved. So we want everyone to understand what is an LLM, what is HuggingFace, what is a vector database, but that there are multiple offerings for them. So we don't want to present just a specific one. We'll ensure that that is understood further on. So offering similarity search, so finding the closest vectors, so the closest terms to some input data, so given query vector. Given query vector, that it might be too technical, the prompt that we are using. So whenever we are querying some LLM, we are usually using what is called prompt engineering, meaning performing a prompt or a search. Any recommendation system, image searching, or anything that might be needed. Near real-time performance, near real-time query performance. The target, again, developers and businesses building those AI applications that want efficient similarity search. Going a little bit further, again, so that we understand the concepts, but we do not stick too much in them because hopefully understandable at a high level. So scrolling back briefly, HuggingFace, the platform which contains a lot of goodies, a lot of data sets, a lot of both community and enterprises built models. The vector database is the databases where we are storing those embeddings. So the shortest summary that I could think of. Hopeful, maybe a little bit more advanced concept and which ties them together, meaning retrieval augmented generation, usually referred to as RAG. That's a hybrid AI approach which attempts or which is used to combine the strengths of those components. So a trivial system, which would be the vector database, and a generative model. So whenever we want to aggregate data from those two sources, as we'll further see, maybe to perform an enriched query or an enriched prompting to which we are sending to a generative model, we can use a retrieval augmented generation, which overall it's a pattern, a data querying pattern. Vast information database to retrieve those documents to inform the generation process. So more informative and contextually rich responses. Bridging gap between models and dynamic data-driven, anything that is more dynamic in modern AI applications. I could further go into the other details, but hopefully the overall concepts are, the overview of the retrieval augmented generation is understood. I'll fast forward a little bit, I'll skip in order to get to, so fast forwarding to leave more time for the demo. I can go back to it, but not that much further context on it. In order to be able to bridge them together, so integrating the models with vector databases, we can use them for personalization, for anything more custom. As we'll further see, there is another technology or another component that I haven't prepared the slide for. It's called LangChain. LangChain is just a library or a framework that we can use in order to link these components together. Meaning the models from HuggingFace, vector databases, I haven't mentioned explicitly embeddings creation systems, but we'll get to them also. LLMs, embedding systems, embedding generation systems, embedding providers in the end, and the vector databases as well. So that's why that was the short overview of what we have. Scrolling back to that, so hopefully now the context, meaning what we'll present, not just this overview, but this overview. So HuggingFace, what it is, vector databases, RAG, and LangChain framework. So to summarize, and I'll pass over the mic to Nicolas very soon, a series of AI concepts which have been available and used historically for a very long time, which have been popularized, especially in the last year, thanks to ChatGPT. And a series of technologies that are enabling and allowing us to work with AI concepts and components in a very easy way. So if you'll ever be interested, I highly encourage you to try HuggingFace or vector databases or the LangChain framework. I guarantee you that you can invoke an LLM, I don't know, either a free one or a commercial one, in just maybe 20 lines of code. So not magic or not complex magic in any way. If you may have any questions, please. Otherwise, I'll pass to the demo because we usually want to see things
I have
moving.
a couple of slides as well. Thank you, Bogdan. That's the first time we are doing this presentation together on the AI. We have been presenting some of the concepts like microservices, migration to cloud, and so on, but that's the first time we are doing this presentation together. So as I was introduced, my name is Nicolas. I have more than 20 years in data science. I'm not that young. And I've been working on NLP, so natural language processing, since 2012. I had my own startup even in Bucharest called Market Science that was doing NLP in 2013 before TensorFlow was even open source. So that was the early days. Okay. So let's look at the technicalities now. But before we go into that, so ChatGPT was released in December 2022. It was the big, the ChatGPT moment, and everyone started to consume it from the UI, okay? So we start with the kind of columns on the left. And progressively, it has been embedded in some company's platform without any add-on, anything else, but simple access to the... And people have been starting to use that. When I've been polling some people in the business, not in IT, they reveal that probably 60 to 70% of them are already using that at work, whether there is a company policy or not. Okay, that's where we stand in 2023, and some people, probably most of you, have been experiencing with trying to connect this LLM into your internal system. But the question to put that in production is still probably pending for most of you. And we were talking about closed source LLM, okay? The ChatGPT, the Llama, etc. Okay? And progressively, we are getting more confident with this LLM. We can probably, as engineers, minimize one of their main problems, which is that sometimes they hallucinate, thanks to a couple of tricks. The one that Bogdan already introduced, the RAG, the retrieval augmented generation. We can fine-tune the model, meaning that we can improve or, let's say, add a final stage of training, but we won't go into this detail. Or we could start from scratch, but probably very few of us, because of the cost and because of the technicity of it, will go in this direction. So most likely, software engineer will concentrate on these two aspects. It can be a mix, it can be one, it can be the other, but that's what they're going to do in 2023, okay? And they will use, most likely, some of the tools that you see the logo at the bottom, okay? So, yes, one of the things that has been very frequently contested somehow is the hallucination, the fact that we miss some fact. And let's face it, the very early stage models that we have been working on from ChatGPT 3.5 were hallucinating a lot of things. So if you look at, for instance, medicine, research, etc., many of the quotes that they were given there were pure hallucination, so 45%. But if you go to some more performing model, like bigger, they start to be better. But the real thing is really when we start, and we talk, let's say, of a compound generative AI system, meaning that we will have our LLM within a broader software solution, okay? And RAG is one of the examples, okay? And if we do that, the hallucination is being reduced to 5% because of some prompt engineering tricks, like a chain of thought, etc., but also because we are providing some information from some internal knowledge base, okay? So we can reduce by a factor of 10 easily by just moving from GPT 3.5 to, let's say, a good system, not necessarily the state-of-the-art LLM, but a good system plus plugging it to some internal database, okay? Okay, so this this architecture, the high-level view of it, is very, very simple, as Bogdan said. So we have an internal documentation. We will chunk these documents, because most likely they're going to be too big or too diverse for the purpose of the call, the prompt that we will generate. And we will do an embedding. So everyone understood what is an embedding? Yes? It's very easy? Okay. So we'll take chunks of the documents, and these chunks are going to be transformed as vectors. Okay? Very simple. And we will use for that some embedding vector, the embedding model that is available at HuggingFace. OpenAI has a very famous also embedding model, ADA 002 or 003. But we won't use it for this example. We stick to the, let's say, open source tooling. Okay? So once we have done that, we will concatenate all that into a prompt that is much bigger. It will be augmented. Augmented by what? By the relevant chunk. And these chunks are what? Are essentially information that are very close semantically from the question that I have asked. So, but instead of doing this matching, this similarity based on, let's say, keywords, that could be one way, we use as we look at the chunk, and it has been transformed, and therefore the similarity is based on some other distance metrics than a pure keyword matching. Okay? And thanks to that, we will improve drastically the performance of the model, the system, and reduce the hallucination. Okay? So in the field, we mentioned already that there are several frameworks that allow to compose such systems. We will use one of the earliest in the open source field, that is Longchain. Llama Index is pretty good as well, and very interesting to follow because they really go deep into the, I mean, as usual, it depends, the technicalities of the implementation of such system make it very, I mean, it's engineering, it's complex. Prompt Flow is developed by Microsoft and essentially used on Azure. You can use it elsewhere, but I think these two first solutions, Longchain and Llama Index, are the most popular. Yes. So I put here the logo that we're going to use. We're going to use GitHub, actually, as a source of our internal knowledge. We will retrieve all the issues that are being still open or closed on one particular repo, and we will use that to enrich the prompt that we generate. We'll use Longchain for the orchestration to chunk our text, etc. We will use HuggingFace model for the embeddings. We will use Facebook AI similarity search to perform the retrieval of information and store it in a vector database. And Mistral AI, the first model open source, what was it, September, October, by this French AI startup, Mistral, which is 7 billion parameters, which in the context of generative AI is a small model. So let me just, I just want to be sure that I don't lose the connection, as it is once again not fully deployed. Okay, so in order to replicate this demo, you just need to have a GitHub account and, I mean, generate a token.
If you may want to do that, of course.
If you may want to do that.
Otherwise, we'll present it.
Yes. Initially, it was supposed to be.
Yeah, it was, exactly. It was supposed to be, but we shortened it.
Okay, so you don't need to have an account on HuggingFace. You can, of course, but it's not required to replicate the exercise that we will do. Yep. All done. Okay, it's not that simple to associate a prompt to its relevant context. If you do that automatically, there are many sources of potential problems. That's where, when we go deep, we realize that associating a prompt to some relevant information that we could provide in the prompt template is not that easy. So if you want to go deeper, and that's one of the, let's say, the chart, the graph, let's say, shared by Llama Index, which is going very deep into all these, let's say, details. It's very interesting. Okay, I'll go faster. Evaluation. So once we generate some enhanced solution, the question will be how to measure the accuracy, quote unquote. So we will not necessarily talk about accuracy in this context, but more about context adherence, about quality of the output, and there are now new solutions that allow to look at all that. So maybe the high-level view is to say that we have our foundational model that is here, highlighted. It will be connected by to some external data set, converted as a embedded vector, and then on top of that, we will do in production, we will have all the monitoring. And you have a couple of KPI that could be measured: context adherence, are this question fully answered, source attribution when we have different chunks, percentage of the chunks that are being utilized. So there are a lot of things that we can consider to really monitor the quality of the system that is being put in place, being put in production. Okay? And as usual, this is our long chain. Yeah, we could go simpler. If you look at the architecture of Microsoft Copilot, that is very famous and being rolled out in many organizations, well, it's a RAG system, a bit more complex, of course, but essentially it's the same principle, getting connected to some internal knowledge database and retrieving and enriching the prompt in order to get appropriate answers. Okay, so let's look now at the demo. So we call it a vanilla RAG workflow for GitHub issues. Why vanilla? But the answer is very, very simple. We'll have only one call to generate the answer, but we could have multiple calls. There are many ways of, let's say, enriching the way you perform the answers so that you get better accuracy, better alignment with the user expectation, etc. Huh? Okay, so in order to proceed, we need a couple of libraries that are, let's say, common in this domain. The most famous one is the one from HuggingFace transformers, which is not very related to the transformers architecture. I think it's HuggingFace transformer. Some of the...
that's correct, yeah.
There are a couple of other libraries that are being required to replicate this demo. Accelerate, which is allocating, let's say, computation to different GPUs. Bits and bytes, which is used at the moment when we quantize the model, because the model we are using, the Mistral 7 billion, is fairly large, so we'll use a quantized version of it. So we need this lightweight Python library for that. Sentence transformer is used for the embedding, and face GPU is our vector database. Okay. So once we have done that, we need to install also a long chain. And then, so there are a couple of, let's say, very simple things. Access to GitHub that is being required, because we will we'll pull all the issues for a particular project. And we chose for this example, actually, we are using an example that was published by HuggingFace. And they have this HuggingFace PEFT. I hope it's visible from your side, which means parameter efficient fine-tuning. Because what we're going to take is that we're going to take a model that is on HuggingFace and install it on our Google Colab backend and proceed with the RAG. We don't do anything on this model. I mean, we don't do anything. But we could think about fine-tuning it. We could think about retraining it on an internal database so that the model has a bit of understanding, a bit of knowledge about what we do internally. It's an interesting direction, and usually, let's say, advanced AI engineers are combining them both. But I think it's, as a starter, it's probably better to think that actually an LLM is a reasoning engine. It's not a knowledge expert. Huh? So it has some knowledge about everything. It has been trained on the petabytes of data, so it's obviously a lot of knowledge that has been accumulated, but it's not, let's say, very, very accurate. So the best thing to think about it is that, yes, it's a reasoning engine, and therefore to plug it to some real data is very helpful. So I think as a starting point, in your journey towards AI and towards better accuracy in all the prompts that you can get, the RAG is better than fine-tuning. Okay? But still, for the example of this for this demo, we'll connect to HuggingFace parameter-efficient fine-tuning, retrieve all the open and close issues, and see to what extent, if I ask question about fine-tuning, Mistral 7B is actually better with or without this context that we have retrieved. So once we have retrieved all these, let's say, issues, so we have text. We'll need to split it. So we chose arbitrarily, but it's kind of common in the field to chunk the document of different size with a slight overlap to not lose context. And 512 tokens. I hope everyone is familiar with a token. What's the difference between a token and a word?
Splitting.
You have an answer for that, Bogdan?
I was thinking about a very simple one.
So what's the, let's say, the order of scale? Or what's the?
One to many.
Huh?
One to many between the
It's actually not that much. So a token is probably no more than 3 or 4 characters. Yeah, but exactly. One way to, in the context of English, for one word, or for 100 words, 100 tokens, you will have 75 words. So if I say calling, I am calling you, call, and ing will be separated as a token. Okay? So it's a way to proceed with semantically with words. So what we see is that each of our chunk is going to be cut by 512 tokens, and there will be an overlap between them two of 30 tokens. So that there is once again a bit of interaction between the chunks. They are not completely independent, but somehow they share a bit of common information. Okay? So there are various text splitters that are available with long chain, and we have been testing this one, but some of those are very much similar. I think there is no real...
Depending on the task, usually. So
yeah.
It's always depending on what do we want to do.
Yeah.
Yep.
Okay. So then once we have these chunks, the question is, okay, we're going to transform them as embedding vectors. We're going to use for that face. Sorry, we're going to put that. We're going to create yes, I see embeddings. That's the name. So in order to select the embedding model that we want to use, there is one famous page, which is this one, the leaderboard on massive data, which is actually assessing the different embedding models that exist. Once again, they are on the shelf. You can just click access to the page and downloading or using it automatically. So what we did on our side is that we used something that is very generic. We are not in, let's say, in performance research at this level. Okay? Okay, so once we have done that, no, sorry, I didn't finish to comment this part. So we also set up a face, which is a very impressive library to proceed both the storage of our vectors and the similarity search. There are different ways of doing similarity search. One that is very common is to, as they are, let's say, vectors, you can use cosine similarity. So you will measure the distance between your vectors. That's one way to do so. And the other way is to think about in terms of pure distance. So there will be the distance between the two embedding vectors. In this case, what we chose to do is actually to use the kind of an Euclidean distance between our chunks and the prompt. Why k equal 4? For the very specific reason is that we will keep only the 4 closest, the nearest neighbor of the prompt. So we write a prompt, we embed it, we compute the distance to all the chunks in our database, and we keep only the 4 that are the closest to this prompt. And we will concatenate that somehow into a prompt template and pass that to the LLM. Okay? So as you see it, the first 4 are being selected, and that's it. So that's kind of what we call stuffing. There is no priority. We could have taken the first one, see the answer, assess the answer, and see if the second one could have been better. So we could re-rank, for instance, all the let's say the chunks in order to get better answers. In this case, they are what we call stuffing. We put them in the prompt, and let's go. Okay, now the model. So as we discussed already with Bogdan, this model is Mistral 7B. There is a new version that has been released a couple of days ago. Not yet. So we'll use Mistral 7B fine-tuned beta. And in order also to make it better in terms of speed during inference, we use a quantized version of LLM, of this LLM. So we added here a very simple, let's say, computation that if we were to use the full version of Mistral 7B, we need 28 giga of VRAM in order to proceed with our prompt. So by quantizing from floating point 32 to 4-bit, we get a lot of space being spared, and the quality of the loss is not that strong. Okay, so this is what we are doing here. So this model is fairly large, as you can see where it is. So we have two parts of it. PyTorch is the one. So you see that in total it's already almost 15 giga. And this is the quantized version. And we do not take the model on the shelf and we quantize it in this notebook. No. The model is already quantized, and fairly significantly. It is a quantized 4, and we load it on the here. Then comes how to set up all this chain, and here we use long chain for that. So a bit of setup. So we need to set up the LLM chain for that, and so that's specifying the task. What is the temperature? Do you know what is the temperature?
Yes, the degree of randomness.
Exactly. Yes. And yes.
We're glad to hear people knowing
Thank
the
you.
details. Really
Yes, exactly, and you can do that with a ChatGPT when you are on the playground. You can adjust all that. I think technically we measure the sorry, say again? Yes, the entropy, and the closer to zero, actually we always take the next word that has the highest probability. So when we repeat the exercise, we always take the word which has the highest probability, and therefore the content is always the same. Huh? So in this context, we have 0.2, which is fairly small. We limit the creativity. We are not very interested about that. Some other parameters, like we limit the number of tokens generated being to 400. We don't want too many. And then comes the prompt template. We have the HuggingFace pipeline. So this is what we are setting up. And then we need to, explain how we will concatenate all this information. So we have what we call the prompt template. So we start with the system message. And then what we call context is actually all the chunks, the 4 chunks that we have selected based on their proximity to the initial question of the user. And we will put that here. So the user question comes next, and then comes the answer. Okay? So that's our prompt template. And that's it for that. Okay. So once we have set up this LLM chain, the last thing that we need to do is connect the LLM to the vector database, and actually to the retriever to retrieve all the right chunks. So that's what we do here. Okay, so now we can ask a question. So I've been running all this before we start. It's not fully deployed, it's on a very temporary server. So if we ask what is a RAG, so you understood, it's retrieval augmented generation in our context. So let's look at what is being created. So you see that it takes some time. It's not like instantaneous. So you see also the setup that we have here. So we have a V100 of NVIDIA, which is kind of already an old generation of GPUs. And that's it, only one. So let's look at maybe the setup, it can be helpful. Do we see that? So yeah, so GPU, okay. So that's what we have here. Okay, so let's look at the answer, and I think it's going to be better formatted like this. So you see that we have the initial, the prompt, what is a HUG, and then the answer. And in this case, what does it say? Is a tool used in project management? Probably not. So out of context. It may be right, but that's not the expected answer. Huh? Yeah. So now that we have that, let's do what? Let's ask the retriever about all the chunks that are the closest to what is a RAG, and let's proceed again with both context and question.
Which is the actual retrieval augmented generation.
Exactly. Yeah. So far it was without. So let's look at what it says. A RAG, a risk assessment group, is a group of individuals who is responsible for...
Still.
So why it doesn't work? Because it doesn't work. Sorry?
Yeah, the temperature was low, yeah.
Yes. I believe that actually we are providing contexts that are completely irrelevant in the context of a RAG, because we are talking about fine-tuning, which is a very different context. We talk about parameter-efficient fine-tuning. This is the library. This is the repo from GitHub where we collected all the issues. So that's very different. So actually bringing some context doesn't help at all. But let's ask another question. How can I combine several or multiple adapters? What a weird question. Okay. So once again, I go and ask for the answer to Mistral 7B quantize without any context, additional context. And what does it say? So the answer, to combine multiple adapters, you need to ensure that they are compatible with each other and have the same voltage rating. You can then connect it. So what do you think is replied by Mistral? What is the adapter here that he...
Electrical.
Yes, yeah. Like, I don't know, on your mobile, on your something. Huh? So it's true, but out of context. So let's do it again with some of the chunks that are possibly retrieved. So most likely the word adapter is very important in our context. So you see that I've been asking the retriever to, based on the question, to give us back the four closest chunk. And let's go here. So let's do a bit of analysis. So what do we see? And this is the full prompt template that we see with the first, let's say, system message. Then we have the four documents that are, the four chunks, sorry, that are being retrieved. And I say document because one way to separate them is to look at the word document. So we have 1, 2, 3. Is it correct?
Yeah, and the fourth one is...
You see, I'm lost. So there are four documents that are being sent, stuffing, without any priority to the prompt, inside the prompt. So then the question, how can I combine multiple adapters? Can you please provide to use? So here we see that it's right in terms of context. But the answer is, the answer is a bit stupid. It's not responding according to our expectation. Huh? So maybe let's do it again. Let's do it. Where is the question?
I think further up. Yeah.
Okay, so I will just call retriever and then go back to my full RAG pipeline. And then
Maybe iterating over the...
it's the same answer. Unless I've iterating on over what?
On each document to just display the page content. Maybe we can see it more easily, but it won't change.
We could change the temperature and see if we get better results. Sometimes I get good results. So what we see is that, and maybe that's one of the limitations of the demo as it is now, is that we are taking a lot of noise here. So the context is not very, very clear. If I were, let's say, connected to internet, which is a knowledge database, for instance, something like this page, and providing that within my RAG, for sure, I would get much better results. So adapter in this context, you see that adapter-based methods add explainable parameters after the attention and fully connected layers of a frozen pre-trained model. Okay.
Most likely it needs more context,
sorry.
Thank you.
So, well, at this stage, it's not necessarily always the best, the relevant answer. Sometimes it works. This morning when we are training, working with the model, it gives good answer, but sometimes it doesn't, and probably that the issues that we are collecting are not that good quality and not very informative actually to provide better context. But still, it works. So how could we go further, Bogdan?
I think improvements could be done maybe either by changing the data set that we are exploring, because in this context we are using as data set the HuggingFace path repository, so you analyzing
it better.
So, yeah, exactly.
So what could be changed also?
That's one improvement that I can see, the input data. So because all the data that we are storing in the database is taken from there. So changing that, or maybe adjusting the temperature, or maybe adjusting
the model? Yeah,
the model as well, because that might be just what that model can do. So several adjustments which can be made from here on, but this is mostly an let's say an improvement. An improvement in terms of variating the components. But maybe the biggest one would be the input data. Because in this what it is providing, so to combine you need to ensure they're compatible with each other. It is pretty much or pretty easy to see that it is not understanding which types of adapters are we referring to. Or maybe providing the question, improving the question. So prompt engineering, enhancement, improving the question that we are asking it.
Agree. So what we saw, as you mentioned, is kind of a pattern. What we are doing, our RAG is a pattern, and the embedding models is our choice. The model that we have been using, the Mistral, is our choice. It has been quantized, is our choice. The type of metric that we use for the similarity is our choice. Exactly. What else? So there are many, let's say, parameters, many, say again?
Many variables, and
yes.
One of the biggest that I see in our context is the input data, meaning you have specified the HuggingFace. We have specified the HuggingFace path repository. If we are referring to something else, so providing some better input, that would provide a different output as well. So that's my...
So what I like with RAG is that we are getting closer to software engineering. Is that we are no longer training models based on large data set and pure AI engineering. So this is what I think is very interesting. Taking model off the shelf from HuggingFace and try to work with them in the context of our software engineering work. So I like it very much for that. You could also, that's something that we want to assess also, is to say that, oh yeah, this this open source model is very nice, but at the end of the day, I don't care that much. I could call directly OpenAI, ChatGPT 3.5 Turbo, which is not that costly. It's still more costly than to run this model, but it's not that costly. And therefore, it could be a good alternative.
This is one of the several components which can be could be improved, meaning the LLM, the used LLM. I mean, instead of using Mixtral, we could use, of course, the OpenAI or any other, but OpenAI might be the reference one. Or Grok.
So usually in many, let's say, demos that exist online, they use OpenAI embeddings and OpenAI API calls. So it's full OpenAI. In this case, we want it to be full open source.
Yeah, we want
or
to do
full
something
open weight. I don't know what to say, because the model may not be known, the architecture, but the weights are fully accessible, and you can fine-tune the model. Okay, that's it for now. Thank you very much. If you have any questions.
Thank you.
Yes?
So apart from the initial loading of the documents from the GitHub,
Yes.
does this do any external calls at all, or is it all internal?
No, it's all internal. Yeah, it's all internal.
You can load like any types of documents.
Sure.
Yeah,
Actually,
exactly. That's what
there
I
is
was
there is a
referring to.
use case that I like very much for me, for instance, is to connect it to some of my Google Drive folders.
That's what I'm building.
Yes, I love it.
Or PDFs, or that's one of the best use cases. Yes. Yep.
Knowledge database.
Yep. And whoever wants to play with an AI, a self-developed AI solution, I think that's the best solution. Just to integrate very easily using Hugging
I
Face.
started with HuggingFace as well, but I tried to train it on the documents.
Ah.
It didn't get any.
You did the fine-tuning part?
Tried to do the
Yes.
fine-tuning
Yeah,
part, but I'm just starting, so I don't really understand most of the.
Before doing that, or as an intermediary stage, you may just insert any documents that you may want in a database, and then to use an LLM to query it. That would be also, it will know your data and it will act on that data. So that's a much simpler, I mean, it's a step towards what you want to achieve.
So it happens that we have been using Face for the sake of this demo, but in many, let's say, standard databases, you have already this ability to store vectors and to do the similarity search. Postgres is one example.
PG vector, yeah.
Second?
With PG vectors, Postgres
Yes,
with PG
yes.
vector, yeah.
What else? I read that CosmoDB on Azure is doing that, and it's actually the way OpenAI is working. They use CosmoDB at scale.
Pinecone, some others, ChromaDB, so several.
So yeah,
solutions,
using a dedicated vector database for that may not be, let's say, absolutely compulsory in the context of your business.
Definitely depends. So it depends on the use case. But for whoever wants to try an AI solution, I think that's maybe the hello world would be just to invoke OpenAI or something. So very easy. And the next one would be to just insert some data, so to process your own documents and to insert them in a vector database and then to query that data. So the results are very, very, very nice and very impressive. And using no problem. Absolutely no problem.
Yes, so there are a couple of solutions now that are being proposed to monitor that more specifically. I'm thinking, for instance, at Galileo. I think Galileo.
I think so.
Huh? Which will, and some of the metrics that we inputted here are coming specifically from them. Context adherence, are question fully answers, source attribution, and chunk utilization. So that's one way to ensure that if you know that the answer is in your documents, the question is how you proceed with the chunking, with the type of metrics for similarity, etc. So that could be the source of problems. If you know that in your database you have the answer, the question is how to retrieve it, to make sure that it comes on top of your retriever.
And some fine-tuning using reinforcement.
I like very much Galileo. I've been looking at their solution online. They have a couple of webinars I recommend. They are good guests. But their metrics are proprietary. They sell that, actually. So that's their business. Any other question? Yes. Yes.
I was curious about this. In the Google Lab, we have this context that was like document array.
Mm-hmm.
So as an
loading of data, yeah.
But if you have like a very large document database, would it still work well?
So Face is able to work with billions of documents.
Yeah.
So actually, it's completely over-engineered.
It would be a sort of divide team around those documents, so just iterating through them and just chunking them and then inserting them in the database. So it definitely works with larger documents as well. So the recursive chunking that I think it was one of the classes that was used, that's so iterating over some documents, chunking them and then inserting them. You can consider like a sort of fork join from a pattern, from a processing pattern. Make sense?
So it's completely over-engineered. People would probably use something lighter, even in memory. You could have a vector database in memory in order to proceed with, let's say, simple demo. This is ready for scale. This is probably something that Facebook is using, actually, in production.
Of course. It was developed by them and used by them. So essentially, either on-premises databases, meaning local databases, Feist is one of them. I think ChromaDB as well, Postgres using the PG vector, or some cloud-based solutions, Pinecone and some others. So depending on your needs. For something, if you don't want to set up something locally, Pinecone would be a very easy solution. So the setup is done in, I don't know, 5 minutes. So definitely not rocket science setup. I mean, using LangChain and using, especially using LangChain. Very straightforward.
Yeah, I think for a software engineer, it's a piece of cake.
Yep, PG vector. Postgres with PG vector. There is just an extension that can be used in Postgres. So I'm not sure about the performance, but if you ever want to check the performance, Feist versus Postgres versus the others versus Pinecone, I have seen on the internet several comparisons. But for testing purposes, definitely works. I mean, not production ready, maybe in terms of performance, but for testing, definitely it works sufficient.
So in the example, maybe some of you know about Gabriel Preda. I think he's working for Endava. He released this interesting notebook. You see that it's somehow the same setup with Llama 2 instead of Mistral, but it's the 7 billion.
LLM, yeah.
And he's using ChromaDB as a vector database. So there are a lot of solutions, probably too many to survive, but that's another question.
For the programmers that are aware about the concept of interfaces and implementations, you can just consider those components as interfaces and with several implementations. Easiest way to understand them. So for any database or for any vector database or for any LLM, think of them as interfaces with several implementations, either local or in the cloud. That, in my opinion, that would simplify things a lot.
Yes?
I think several solutions for that as well. Besides the Google Colab, HuggingFace would be also a solution to do that. So if you want to use HuggingFace, you can very easily deploy it in a HuggingFace space.
Yes. Okay, I'm sure it's like a really...
I highly recommend the HuggingFace spaces. So very easy to use, and you can just integrate.
So if we go to the page where we downloaded the model, I can deploy in one click, you see? I can deploy on Azure, Amazon. I can...
see the usage from there. And you can also present the spaces if you want, Nicolas.
Yes, yeah, actually, yeah. It's similar to GitHub. You have some, you can, let's say, commission, take some machines, virtual machines, and start working directly from here. And
the space would actually be a Git repository. And in that Git repository, you can create a Python program which will just invoke whatever you may want to invoke from HuggingFace or from anywhere else, but mainly from HuggingFace, and it's just deployed on their premises. There is a free hardware configuration which is not that powerful, and of course, as with any drug dealer, the first doses are free and the others are just paid. So essentially the same pattern. Or freemium if you want.
So it's very similar to what we can do on CodeSpace.
Yes, as with CodeSpace, but the usage in HuggingFace, it's very, very, very simple.
Yeah.
So whoever wants to explore,
And yes, was part of the first demo that you can
We
deploy
presented.
that very, very quickly with a Gradio to your internal users. That could be nice if you want to iterate very fast during the development of a RAG pipeline. So that's, yeah.
You've also mentioned running them locally. Of course, that's also an option. It's always an option, but please be aware that any local usage will most likely won't be so performant, because you would need a very powerful machine. So that's why offloading the execution to the cloud, to any, I don't know, HuggingFace or any other, either on their default hardware configuration, or maybe if you want on a more powerful one, in my opinion, it's much easier and easier to set up, and why bother setting up so many moving pieces and the huge hardware requirements. So play with them. Thank you very much for the questions. And thanks for everyone.
Yes, we have a bit of a time. Thank you very much.
Thank you.